The huacas of South America represent the most astonishing manifestation of stone shaping in the world, one that equals, or perhaps even surpasses, polygonal masonry in its significance. In this video, I will try to present them from a different perspective, since these objects are still often perceived merely as thrones or places of worship. The first thing to do is to outline the systemic data concerning these sites. This was done most effectively by Vladimir Pyatkin, whose work I will follow with some modifications. He identified that the stone surfaces are not random selections of rock but specific types forming stable combinations. The first type, resembling stone seats enclosed on three sides, consists of a horizontal surface bounded by three vertical ones, triple forms. They have several distinctive features, such as the preservation of a section of rock between two adjacent elements located at the same level. This ensures the presence of side planes and explains the very existence of such a detail, which would otherwise be redundant if this were simple quarry work. A side plane can also be created by placing two elements at different heights, forming a commonly recurring combination. In some cases, the side surfaces may be rounded, thus merging into a single whole. In such instances, the proportions tend toward a 1-to-1 ratio. Similar elements could even be considered a separate class. Another deviation from the classical form appears when the object is not created by cutting into the rock, but rather by leaving a protrusion. In that case, the proportions remain the same, 3 vertical planes and 1 horizontal. Such a protrusion could be viewed as an inverse figure, although it is most likely a distinct type. Moreover, it occurs in large numbers only at Uruk Rumi, and therefore should be regarded as an exception. The second type, a recess formed by 2 perpendicular planes, can be called a double form. A series of such shapes creates something resembling steps. For example, the so-called Andean cross represents a combination of such elements adjoining a common surface. Both the first and the second types should be distinguished from objects that are actually seats or steps, which is easy to do by considering their size and location. The third element, niches. In rock outcrops they are always rectangular, sometimes nearly square, unlike in buildings where they are invariably trapezoidal. In fact, niches are also sets of 3 vertical and 2 horizontal surfaces. A notable property of niches is their individuality. In rock formations, they never appear in uniform rows, while in buildings, they do. Thus, the triple and double elements form combinations of multiple identical or similar units, while niches do not combine among themselves but can be associated with the triple ones. The fourth element, the plane. This is a leveled section of rock, sometimes taking the form of a niche with very small side walls. It can be positioned either at an angle or vertically. The fifth element is the G-bosses. We usually see them in buildings, yet they also frequently occur on natural rock formations. Formally, they can be considered inverted elements. That is, if the previous ones were formed by removing material, by recessing, then it is only natural to expect their opposite, protrusions. However, this assumption arises more from a desire for logical completeness than from the actual state of things. G-bosses can be cylindrical, spherical, or rectangular. They are often interpreted as remnants of the bridge that once connected a block to the bedrock in a quarry. This interpretation is incorrect since, like the previous elements, G-bosses often form combinations that cannot in any way be related to the detachment of a block. Moreover, as mentioned in the first part, in Peru blocks were not quarried by cutting them out from the bedrock. Loose deposits or fractured sections of rock were used instead. Therefore, G-bosses should be regarded as independent elements. The sixth element, smoothly curved surfaces forming passages. Very often these are naturally shaped rock formations that have been additionally refined. Within these surfaces, previously described elements may also be present. Thus, the combinations and spatial arrangements of these 6 elements create the full variety of geometric forms observed in the Huacas. A separate issue concerns how these elements are positioned relative to each other, their similarities and differences compared to architectural structures, the different levels of their realization, as well as their analogies and contrasts with constructions in other regions. It is possible to identify a common underlying principle among such diverse structures, though this should not be taken as evidence of a single proto-civilization. Quite the opposite, in fact. This topic I will leave for future videos. Now, let us turn to the question of purpose. To do this, we must first examine what these objects clearly are not. Two main explanations are usually proposed: that they were quarries or training sites for stoneworking. That they are not quarries has already been mentioned repeatedly. A sufficient argument is that extracting an entire section of rock with such complex geometry would be practically impossible. And even if it were somehow done, such a piece of stone could not be used as a block. The idea that the mountains and rocks were once soft and that the material could be scooped out with a shovel hardly deserves detailed discussion, not to mention that the traces left behind would be entirely different. What we are dealing with here is the deliberate creation of specific geometric forms, which leads to the second version, that these were places where people learned to work stone. First of all, it should be noted that all the elements are executed flawlessly. There are no signs of incompleteness, errors, or experimentation, no traces of training. What we see are precise sequences with an internal structure. Unfinished elements occur only in isolated cases, and are therefore exceptions. There is no reason to assume that this was a place of learning. Rather, it seems that the work was suddenly halted for unknown reasons, and the knowledge of producing flat surfaces, in fact, would not have been of much use, since polycurve masonry requires a completely different type of skill, the creation of curvilinear forms. And one learns this best by making actual blocks, not by working on an orderly set of strict geometric shapes. By the same logic, the blocks of Tiahuanaco could be regarded as the result of entrance exams to a stonemason's guild, rather than as finished structural units. But if neither of these explanations fits, then what was the purpose of this stone creativity at all? The level of interpretation depends largely on one's usual informational context. Some will see here a purely sacred meaning, others will propose astronomical correlations. Some will emphasize utilitarian purposes, viewing all this merely as a collection of stone seats and stairs, and indeed, such objects do exist, as can be seen, for example, at Keniwani. As for me, I would note that the planes made on rock outcrops, from a physical point of view, would serve to modulate acoustic vibrations. This interpretation allows us to explain nearly all components, including the G-bosses, though it still cannot unite all elements of the polygonal complexes. The buildings, water channels, geometric formations, and underground structures, such as tunnels and voids. That is, acoustic interpretations certainly help to reveal certain patterns, but the actual purpose lies on a much deeper level and requires an interdisciplinary approach to study. The acoustic effects themselves may, in this case, be a side result of creating the correct forms within the rock. Nevertheless, even at this stage, one can notice that such a system could only be created either by those possessing the necessary knowledge and tools, or by someone guided by an extraordinary intuition. It is quite evident that the elements occupy strictly defined positions. In many cases, the builders could have shifted slightly to avoid cracks, but they did not. This would make sense only if each plane contributed its own harmonic, and therefore had to be placed in a precisely determined location. When it comes to scattering acoustic waves, the solutions are simple, regular, repetitive forms. But if the goal was to isolate certain frequencies and combine them into something complex, then it remains unclear how such a task could have been accomplished in antiquity. It would be a challenge even today. According to the chronicles, the huakas were points of intersection between worlds, places where humans communicated with spirits. It is quite possible that, at certain moments, specific frequencies emerged out of the white seismic noise and natural resonances of the rocks, producing sounds near the threshold of audibility, sounds that could be perceived as voices. Therefore, paradoxically, this rather exotic explanation does not contradict the views of mainstream science. It even supports them. It simply suggests that we are not dealing with ordinary worship, but with the creation of complex self-sufficient structures possessing dynamic characteristics. Thank you for watching. See you next time.